So there's some rule. This is a way to get around kind of specific cases and say, in general, any type of problem we do is going to follow this setup. Now it's going to be our job to define what is this capital X, what is this capital Y. When we're talking about sequences in series, capital X and capital Y are pretty easy. 1, 2, 3, 4, 5. But when we're talking about other things, exponential functions, X can represent what? What can X represent?
Anything on the line.
Any real number. Any real number. Any number on the number line. If I can draw the number line and I can put a point, I can represent that's an element X of that. And we would say X is an element of all real numbers. Okay, so you've seen this before in pieces throughout the year. Nicholas?
What is that curve E?
This?
Curve E.
Element.
Element.
Element, yeah. Sorry. So this is element. It's an element. It means it belongs to it. So if I were to say, don't write this down. If I were to say, X, a person is an element of fifth hour math.
That would be nice.
If I said Haley, is Haley an element of fifth hour math?
Yes.
Absolutely. If I said Angelo,
What?
would Angelo be an element?
No.
Yes.
What? Yesterday he wasn't, but that was only because he wasn't here. If I said someone like, let's go with, I don't know, Miss Vasquez.
No.
You say Vasquez?
Vasquez. Thank you. I'm saying it wrong. Okay, so Miss Vasquez, is she an element of fifth hour math?
No.
No, she's not here. She's not in this class. That's what that means, guys. Whatever this little x is, it has to belong to this parent group. It can be integers. It can be real numbers. It can be imaginary numbers. It can be numbers that are divisible by 3. It can be any of those. You've got to be able to read this and say, okay, what is this capital X supposed to represent in this case? Okay? Any questions on that? All right, so let's go to exercise 1. Hey, I gave you the answers. Okay. So, on the back of the first page is exercise 1.
Why are we starting from the back?
Back of the first page,
Right after the front.
because the first page was the warm-up. Oh. Okay.
Are we gonna be
If you're just joining us.
Are we gonna be turning Sid?
Okay, no. These are for your notes.
Taking pictures of me. Snapchat.
So, example 1. F, maps. All right. So what we're asked to do is if we've got this, and it equals 1, 2, 3, 4, 5. We want to find out what happens when we map this to our y. What does y equal? And we've done this same equation 15 times now, I swear to God. No! Ryan,
X.
do what?
2 to the X.
Okay, so x, each of these elements is mapping to 2 to the x. It's mapping to 2 to the x.
Isn't 2 to the x squared?
No, that's different. That's a quadratic. This is an exponential. So, what's 2 to the first power? 2. What's 2 to the second power? 4,
Do we just write down
8,
y?
16, 32.
Wait, do we write that as our answer?
So, for part 1, oh, I forgot 0. We'll skip it, we'll go with this. For part 1, if you're asked what is f of 0, well, We didn't include it up here, but what would f of 0 be?
0.
1.
1.
Anything to the 0th power is defined as 1. So in this case it'd be 1. F of 1,
But wouldn't it be? No.
yeah?
No, that doesn't make sense. 2.
2. F of 2, 4. F of 3, 8. F of 4, 16. And then F of 5, 32. Okay. If we're to map these things using a diagram, the same exact representations we had this morning, or earlier on, guys, I need you not talking. The same exact representations we had on the warm-up. All displaying the same information. But this is a discrete version of this problem. This is a finite amount of information. When we start talking about an infinite amount of information, we start talking about equations of lines. We start talking about formulas that actually graph these things.
Do we already do that though?
So, let's talk about this then. What is the range of this function? What is the range of f? John? What is the range of f? We've talked a lot in the last few days, so let's go back to what is the domain of this function. And what does domain mean? Can someone refresh our memories? What is domain, besides Brennicky? What is domain? Carlos, what is the domain? We've talked about it for many days. We've talked about it for many, many days. What is the domain, John?
It's, what x can be.
Okay, it's any value that x can be. In the context of this problem, our domain, x, is an element of x.
Big X.
Exactly. That's our domain.
Oh, because
Okay.
x is the, right, okay.
Alright? So in this case, our domain is not even all positive integers. Haley.
It says assign each x and x to the expression 2x.
That's all those numbers.
That's the answer, so then what does it say when it says complete the following table using the definition of f to x squared?
Complete the following table. So, here's our table. F of 0 equals 1, f of 1 equals 2, f of 2 equals 4, f of 3 equals 8, f of 4 equals 16, f of 5 equals 20. Here's our table. It's not horizontal, it's just vertical. Okay? We got that because 1 maps to 2 through this relationship. I plug in 1 here, it's going to map to 2. I plug in 2, it's going to map to 4. I plug in 3, it's going to map to 8. Does that make sense?
No.
Okay, where am I losing?
And you say that, I don't understand why there's that line with the arrow.
This is just a notation that says x maps to 2x. 2
What
to
do you
the
mean
x.
by maps?
I mean, it's a function, it's a rule. It's just a pattern that we have to follow for this particular example. I could say anything I want. I could say x maps to, let's say, 4 to the x plus 2x minus 3.
So then would you just put the x where we put that x where we...
So if I
So
plug,
they give you the 1, 2, 3, 4, and 5x, and then you fill in that thing with x, right?
yep. So they give me the values for my domain, the values that my x can take. It can take 1, it can take 2, it can take 3. Plug it in and I get out a number. Can it be 7? No, it's not in there. Okay? I'm only given the opportunity to use 1 through 5. That's it. My domain for this function is 1, 2, 3, 4, 5.
But I
Period.
thought,
Yesterday, you
what's the
said that
range?
it could go all the way.
It could. It absolutely could.
Oh, so they're just telling you to do that, so it's just.
For today, our domain for this one problem is specified to 1 to 5. And this is a great question. I'm glad Haley's asking it. Is your domain something that you can always bank on being the same every single problem?
No.
No, you have to look at every problem to figure out what your domain is for that specific instance. Sometimes it's going to be every number. Sometimes it's going to be all positive integers. Sometimes it's going to be every number including imaginary numbers. It depends on the problem. Nicholas?
It says range, not domain.
I know. I was hoping that with domain you guys would refresh yourself so you could get to range.
That's not the answer.
No.
So
John?
is range capital Y?
Yep. So let's go there. So what is our range in this case, John?
Y equals, or Y is an element of capital Y.
Okay. And what is capital Y here?
The second part of the sequence.
Okay. 2, 4, 8, 16, 32. That's it. Okay. Here's the second part. So our range is those numbers, are those numbers. Our range are those numbers. Okay? Are there any questions on that? Alright. I want you guys to work with your partners next to you on exercise number 2. It's very similar, but it's actually testing Haley's question. Is an x squared the same as 2x? And we'll see if it is or not. Okay? So give you guys about 4, maybe 5 minutes. Answer those 2 questions, and we're going to come back and discuss them as a class. Brian?
You should let us pick our partners today.
Okay, you can work with Jenny. She doesn't have a partner. You don't have a partner. It's a match made in math heaven. Okay, so,
There's no such thing.
math heaven?
Yeah.
You're right. Okay. I don't want to say where you really are because we're